And then to be specific, today we're going to be looking at the truthfulness of inequalities. So today we're going to be looking at the truthfulness of inequalities. So yesterday, the last time we met, we discussed the rules of mathematical induction. And I remember on one of our discussions that we made, we said whenever you are solving any question about mathematical induction, you have to go through three steps, which was first you find you find, you test it if the expression that you've been given is true for p of the initial value of n. And then step two, you make an assumption to say that given expression, if it's true for p, for p of n naught, then it's also true for p of k. After that, you also make the third assumption now to say this is also true for um, p of k plus 1, which is just the number after k in the set of natural numbers. And then finally, you make a conclusion to say then if, after proving everything, you find to say what you have gotten on the left-hand side is equal to what is on the right-hand side. You simply now just prove. You simply now just make a conclusion to say, therefore, the P of n, meaning the given expression, is true for all natural numbers, n, or is true for that particular given what's this set of numbers. So we also looked at these examples there. We discussed them. We also proved these questions there, which was just question 2 from your tutorial sheet 2. And then today we're going to be looking at the truthfulness of inequalities. The truthfulness of inequalities. And then the first question that we are going to look at is coming from question 3 in your tutorial sheet, which is just saying prove that n is less than 2 to the power n for all values of n when n is a member of natural numbers. So we can now start. So I'm going to be a little bit fast, just pay particular attention so that you don't miss out some points, because the piece that I'm using, I forgot to charge it, but either way, I'll make sure that at least we finish mathematical induction today, so that next time when we meet, we just start partial fraction. All right, so the question is saying prove that n is less than 2 to the power n for all values of n, where n is a member of natural numbers. Okay, so first thing first, we start first by testing this when the value of n is equal to, when the value of n is equal to 1. Because they're telling us to say n should be in the set of natural numbers. So meaning the first natural number that we have, or the n0 that we have, is simply just 1. So we can now test it when n is equal to 1. We see if it's going to give us something that is true. So when we put 1 where there's n there, we're going to have something like this. We're going to get 2 raised to the power 1. Yeah, so 2 raised to the power 1 is simply just the same as 2. Now you can check the statement that you have here. Is 1 truly less than 2? If 1 is truly less than 2, then you say this statement is true. So after doing that, you can move on to the next step now. You can move on to the next step. So you can move on to the next step. The next step, we said we test for any value or any number in the given set. Here we've been given to say n should be any number in the oasis, in the set of natural numbers. So we're going to get any number. We now make an assumption to say, since it's true for n is equal to 1, then this is also going to be true for n is equal to any number, which is going to be called k. So we're going to call this number, which we don't know, to be k. So we'll also do the same. while there's n in this expression, I'm going to put k. So I'm going to say this is going to be k less than 2 to the power k, like that. So I'm just putting them in brackets so that at least you can be seeing the demarcations. Otherwise, the brackets here are irrelevant. You don't even need them. Okay. So after that, we also make another assumption now to say since it's true for n is equal to 1, meaning this is also true for any value that is going to be just after k. So we said k is any number in a set of natural numbers. So now the number that is going to follow up after k is just going to be equal to k plus 1. Why do I say it's going to be k plus 1? It's simply because when we're counting numbers, we count like this: 1, 2, 3, then we go like that. So as you are counting your numbers in this manner, what will normally happen is that for every value that you have, if you have 1, for you to get the second number, you're going to add this 1 plus 1 to get 2. So if you have 2, for you to get 3, you are going to add 2 plus 1 and you get 3. Meaning for any value in the set of natural numbers, if you want to get the next number after k, it means that you are going to add k plus 1. And then you get your value there. So this simply implies that the next number that we're going to use here will just be k plus 1. So it's going to be k plus 1. So let's now put where there's n k plus 1. We're going to put k plus 1 where there's n in that expression. Okay. We're going to put k plus 1. And then, so while there's n there, we'll put k plus 1. We're going to have something like this. K plus 1 being less than 2 to the power k plus 1. So from there we can now say we can now get this right hand side. So I'm going to get this right hand side. I know to say this right hand side can also be written in this format. Let me just write it properly. So this 2 to the power k, for, let's take for instance, okay, let me write it and then I'll explain. If you have 2 to the power k plus 1, this can also be written as 2 raised to power k and then times 2 raised to power 1, like that. So what is going to happen now is this, we're going to change the sign there. Since we've changed the position, if we've changed this, we've switched it, that's going that side. So meaning we're going to change this, the signs, since we've taken it to the other side of the equal sign. So in this case, our right hand side, our left hand side is just going to be equal to, so our left hand side is just going to be equal to k plus 1. So we want to make our right hand side to be k plus 1, to be in this format, which is k plus 1. So we can now what's this? We can now say where there's 2k, where there's this 2k, we can put where there's this 2k, we can put that expression there. So we can put k where there's 2k, can put k where there's 2k, and then we say these two, which is just here, I'm going to write it there. These two, I'm going to write it there. So 2 times k there, I'm going to get that. So if I want to write this can also be written as what? This can also be written as, this 2k can also be written as k plus k. So when you add k plus k, you get 2k. So from this part, now this is why you need to pay particular attention, because A lot of people miss it just from here. So what you do now on this part is when you look at this k, when you look at this k in this expression on my what's this left hand side is standing is standing in place of that k. Now this one is standing in place of that. Oh, sorry, this one is standing in place of that k. Now, how do I change this k to 1? I was told to say this n should be any number that is positive. Should be any number that is positive. How do I know that it's supposed to be positive? All natural numbers are positive. Natural numbers, there's no natural number which is negative. We define natural numbers as counting numbers starting from 1. So meaning if we say k, yeah, if we say k is there, so we're going to say k in this form. When testing for k for the first value of k, we used 1. So meaning k in this form is any number that is greater than k is any number that is greater than 1. And then in this format, when you have something like this in the expression, you simply get the smallest number there. So the smallest number is 1. So instead of writing k where there's this k, I can just put this as k plus 1. And you can see to say this side, which is the left hand side, is equivalent to this side, which is the right hand side, is equal to the left hand side. I know you may not understand this at this time, but let's move on to the next question. When I explain the next question, that's when I'll allow you to ask questions. Yeah, because here I know, since you have seen this for the first time, you may find it difficult to understand. So if I start answering your questions, we're going to spend the whole time just solving one question. So let me just finish the second question and the questions that are to come, and then I'll give you time to ask questions. Or let me solve the second question and then you'll be allowed to ask. So the second question here is 2n minus 3 less or equal to 2n minus 1. And then we're saying for all values of n greater than 5, n should be a member of natural numbers. So meaning when testing here, when making our first test, we have to take n0. So n0, n naught here, n naught is simply the smallest value of n. And then according to this expression here, we've been told to say n should be greater or equal to 5, meaning the smallest value of n that we should have is 5. So when testing here, we'll not use 1, but we're going to use 5. So let me just test it from there. So while there's n there, I'll try putting 5. So I'm going to say 2 times 5 there will give me, so 2 times 5 will give me 10, 10 minus 3. I'm going to get 7. So I have that symbol there. Then I have 5 minus 2 there. That will give me 3. 2 raised to power 3 is giving me 8. Now, is 7 less than 8? 7, yes, is less than 8. So meaning this condition, rather this statement is true. So if the statement is true for the initial value of n, we make an assumption, we make the next assumption to say this is then also true for the next value of n. Then it is also true for the next value of n. So the next value of n, for any value of n. So meaning in the next step, we're going to test, we're going to make an assumption to say this is also true for any value of n, which is going to be called k. So we put k where there's n there. So we're going to have 2 times k minus 3, and then this is less or equal to 2 to the power n minus 2. And then this is going to be in this way. And then after writing that, oh sorry, this is supposed to be k, not n. So I'm putting k where there's n. So this part can also be written as, let me just do this. Oh, okay. All right. This part can also be written as, this can also be written as 2k minus 3 being less or equal to, this 2k to the power negative 2 can also be written as 2k. If you have gone through the rules of indices, we can write this as in that format. We can write this in that format. So this part is the one that I've changed to that. So we quickly move on to the next value of k. So the next value of n, sorry, not k, the next value of n is just going to be any number that is after k. So that number is going to be called k plus 1. So k plus 1, we test it when k is, when n is equal to k plus 1. So when n is equal to k plus 1, we're going to have something like this. While there's n in this expression, I'm going to put k plus 1. So we're going to have 2, while there's n, we put k plus 1. And then we have minus 3. And then we have this being less or equal to 2 to the power k plus 1 in brackets. And then we have a negative 2 there. So this can be simplified as well. So I can simplify this to this format. So let me write this on this other part. So I'm going to simplify this. This is going to be 2 raised to power k times 2, then everything divided by 2 raised to power 2. So here the sign is going to change because I've brought this part to the other side of the equal sign. So the sign is going to change. And then apart from that, as you can see, there's this part there, this part. So that part which I've circled, okay, is just equivalent to what is this side. So what I'm saying is, when you look at this part here, let me just circle it with a different color. When you look at this part, it is just the same as that part. So meaning where there is that expression, yeah. So while there is this expression, I can put that. So these two, I'll write it the way it is, and then I'll open the brackets. While there is this expression, I can put this expression, since this is equal to that. So I'm going to put 2k there minus 3, like that. So I'm going to have something like this. 2 times 2k, I'm going to get 4k. Then 2 times negative 3, I'll get 6, like that. So here, this, or rather, before writing this, I think I can write this as, okay, let me just do this. The simplest way I can write this to simplify at least my work, I'm going to say this 2 times that can also be written as 2k minus 3, and then plus 2k minus 3. So 2k minus 3 plus 2k minus 3 will give me 2 times 2k minus 3. Okay, so I hope we are all following. So this expression can also now be written as, what you should put in mind is that I'm trying to make my left hand side, my right hand side, to look like this expression there, which is my left hand side. So at least at least I have that 2k, which is just there. So if I want to simplify this, let me just simplify this part so that at least I should know where I'm going. So this 2 times 2k, I'm going to have 2k, and then this 2 times 1, I'm going to have plus 2 in brackets, and then there's a minus there, a minus 3, and then this whole part is equal to my left hand side. So this left hand side is equal to that. So this is the one, this is what I want to get after simplifying this expression. So what I'm going to do now, what I'm going to have here is, I have this 2k, which is there, which is also there. But where do I get the positive 2? Because I don't have a positive 2 there. So if I want to get that positive 2, what I'll do is I'm just going to add positive 2 there, and I'll also add negative 2 there. So what I've added here is simply just a 0. 2 minus 2 will give me a 0. So I'll add positive 2 and negative 2. And then I'm going to say this is going to be minus 3 plus 2k. I'll just write the remaining terms where they are. So this is what I'm going to have. So now it is easier for me to write this expression in that format. So I'm going to say this is equal to 2k plus 2, open brackets, and I mean open and close. Then I'll write this negative 3 there. So meaning after writing this negative 3 and these 2, I'm remaining with negative 2, negative 3, and positive 2. So I'm going to write my positive 2k there. And then negative 3 minus 2, I'm going to have negative 5. So now I've gotten what I wanted, which is just this part. I've gotten this part which I wanted. Now, where do I take this part? Because what I need is just this part. I don't need this part. Where should I take it? That is where now you need to understand things there. In the previous question, that's where we saw the k changing to 1. So even here, let's change this. How can it change now? So we were told to say the value of n should be greater or equal to 5. So we can try to put 5 where, yeah, sorry for that network inconvenience. So we're going to have 2k minus 5. So when you put 5 there, we're going to have 5 times k, meaning it's going to be 10 minus 5. 10 minus 5 will just give you 5. So I'm just trying to replace the value of k there. So 10 minus 5 is just going to give me 5. So this 5, I know to say this 2k plus 2 is also there, is equivalent to that. This negative 3 there is equivalent to that negative 3. So what do I compare this 2k minus 5 to in this expression? We have the 2k minus 5 is going to be compared to 0 because there's nothing here. If we had a 2, we would have compared this 5 or this 2k minus 5 to 2. But in this case, we have a 0. So we're going to compare this to 0. And then let us make this statement true. How can we make this statement true? It's by putting a greater than symbol there. This 5 is greater than 0. That is when this statement is going to be true. And then remember what I said in the previous question, when getting the value of n, the value of k there, I said when k is greater than 1, or when any value that you're comparing is greater than the other, you simply just get the smallest number. So even in this case, after comparing this, we get the smallest number, which is 0. So in place of 2k minus 5, we can put a 0. So we can say this is equal to 2k plus 2 in brackets, and then you have minus 3, and then you say plus 0. So plus 0 is just simply just the same as leaving it the way it is. And then in brackets, make sure that you tell your marker to say, you tell the person who's marking to say, since, yeah, you tell the marker to say, since 2k minus 5 is greater than 0. This is how you write this. It is just as simple as that. So we quickly move on to the next question. If there are no questions here, if we don't have anyone with a question, but this, what we have written here, is simply just our right hand side. Then we can see with our eyes to say this right hand side that we have found is just equal to the left hand side. We know to say the left hand side is equal to the right hand side. Hence, the given expression there, which is this expression there, is simply just is simply true for all the values of n greater than or equal to 5 when n is a member of natural numbers. So do we have any questions here before we move to the next question? All right, let's solve the next question. The next question is telling us to show. So we have to show that this is um, greater, or I mean is greater than a raised to power n. So this is C. Okay, what I'll do is, this one is simple, it's straightforward, it's very simple. So I'll give you this as an exercise, and I'm going to solve one question from the exercise which I've prepared in this the same what's this? So this one is similar to the way I did this part. Is the way the way I did this part is the way you do this other part. So let me just solve some other questions. You are behind on part B. Now the problem is, after erasing this, it's very difficult for me to do assist to retain them. It's actually not even possible. There's no undoing with this software that I'm using. But I'm recording the session though, so there's no problem. You are going to you just find time to come and watch the recorded session that I'm going to send to the group. Yes, you're going to understand. If you still have challenges with it, you can inbox me and I'll explain where I'll manage to explain. But I'm going to send this recorded session to the group. So let's move on to the next question. I'm sure maybe where you were behind sorry, on B, you'll be able to understand in the next question that we're going to solve. So the next question here is telling us to say. So the next question here is telling us to say, show that 1 plus NA, show that 1 plus NA is less or equal to, is less than 1 plus A raised to power N for all values of A greater than 0. So the minimum value of A that we're going to use in that question is simply just, since they're saying A is greater than 0, so meaning we're going to have A being equal to 1. And then they're telling us to say the values of n that we need to have are supposed to be positive, meaning the value of n is supposed to also be greater than 0. So from there, we can now start proving. So we first start with the first thing. So the initial value of n that we're going to use here should just be equal to 1, because we have been told to say n should be greater than 0. And then what we can do now is we test this expression when n is equal to 1 and a is equal to 1. So let us try to put 1 where there's n, and where there's a. So when we put 1 there, we're going to have 1 plus, so 1 times 1 there, I'll get 1 on this part. 1 times 1 we get 1, so meaning we're going to have 1 plus 1. Oh, sorry, 1 plus 1, which will just give us 2. 1 plus 1, and then this is less than, we put 1 there, plus 1, which is going to be 2 raised to power 1, which is just going to be 2. I think this expression was supposed to have an equal sign there. Yeah, it was supposed to be maybe, because when you add 1 plus 1 there, it's also giving us 2 this side. So meaning we're supposed to have an equal sign there for this statement to be true. Maybe it was just a typing error. Okay. So if we find that the first statement there is true, we can go further now to find, to assume, to say this is also true for any value which we're going to call k. So while there is n there, we'll put k. So we're going to have 1 plus ka, 1 plus ka, and then this is less or equal to 1 plus a raised power k. So this, you also do it in a similar manner. You also find you find it when k is equal to, n is equal to k plus 1. So meaning, while in this expression where there is k, I'm going to be putting k plus 1. So I'm going to have k plus 1. Sorry, k plus 1. And then we have a outside there. And then we have this is less or equal to. This part there, I'll also write it in a similar way. I'll put what is k. I'm going to put k plus 1. Yeah, we're going to have something like that. So from there, what you need to do is, you can see this part. So this part, which is 1 plus a raised to power k plus 1, can also be written as, it can also be written as 1 plus a to the power k, and then times 1 plus a, and then to the power 1. So when you multiply this times that, to get back to that, because when you multiply numbers with the same base, you simply just have to add the powers. So what they did here, they multiplied these bases, these numbers, and then they got k plus 1 as their power. This is what has happened here. So this will take us now to the next step. So we know to say what is 1 plus a to the power k. We see this also appearing there, which is just equal to that 1 plus ka. So meaning, while there is 1 plus a to the power k, we can put this expression there. So we can put that expression. So we're going to have 1 plus k a, and then we raise this, 1 plus ka, and then we multiply this by 1 plus a, like that. So when you simplify this, you are going to get something like 1 times 1, you get 1. 1 times a, you get a. Ka times 1, you get ka. And then ka times a, you are going to get ka squared. So here on this part, when you look at it, we can factorize. So when you factorize on that part, we're going to get 1, and then plus. So we'll get something like, remember what we want to get is this part. Let me just change the color. So we want to achieve this, left hand side. We want to show the marker to say the right hand side, which is this part, which I took this side, is equal to that part. So I'm trying to move from this part going to that part. So far I've reached here, and I'm on a part of factorizing. So I can factorize this part, and when I factorize, I'm going to get something like, let me just change the ink. So when I factorize there, I'm going to get k. I'm going to get k plus 1. So I'll get k plus 1 there. And then in brackets, outside the brackets, I'm going to have a, and then plus k a squared. So you can see to say this part here, this part is equivalent to this part there. It's just the same actually. They are equal. We have this one, that one, we have k plus 1 in brackets, k plus 1, and then we have that a outside, we also have that a outside. So what of this part, which one should we compare it with in this expression? Since we don't have anything after this part on our left hand side, meaning we compare this a to the power a squared, we compare this k to the power a squared to what? To 0. And then we've been told to say this a is supposed to be greater than 0. So meaning when we replace a with the least value of a there, which can be 1, and then k there we can put n. N is also greater than 0, meaning we can also put 1 there. We're going to have 1 times 1, which will give us 1, and then we have a 0 this side. So to make this statement true, we're going to say 1 is greater than 0. And remember what I said, if this symbol, so this same symbol is the one that we put there. So ka squared is greater than 0. So remember what I said on the previous questions to say, when you compare two values, you simply get the smallest value. So I'm going to get 0 in this case. So I'm going to put, where there's ka squared, I'm going to put 0. So I'm going to have my expression to be, so the right hand side, is just equal to 1 plus k plus a in bracket, k plus 1, then outside we have a there, and then outside we have a, and then this is the right hand side, but you have to tell the marker to say, since ka squared is greater than 0. So right, ka squared is greater than 0. The time is even up.